All right, well, welcome everyone to Introduction to LaTeX. I'm Clark Iakavakis. I'm the Scholarly Services Librarian here at OSU. This is part of our Data and Donuts workshop series. So if you're not familiar with this, this is a monthly series of workshops on a range of topics related to data, data visualization, analytics. Last month we had a session on creating a poster. In March, are we doing it in March? Is Introduction to Visualization in R. It's a great series. It's a way of expanding your knowledge of different technologies. And we keep it a very low barrier for entry, so you don't have to have any pre-existing knowledge or expertise coming into these workshops. And that's the case for this workshop today. So this is a very beginner, starting with no knowledge of LaTeX. So if you have already authored a lot of documents in LaTeX and already feel like you have a good understanding of the basics, then you might learn a few things about LaTeX today, including using the Overleaf text editor, but it is going to be at a very basic level. If you have questions at any time, feel free to just raise your hand and ask, or just shout it out. Or you can leave them till the end and we can discuss it then. You'll see next to you these two sticky notes. This is from our Data and Software Carpentries, which is another set of workshops that we host here in the library. If you're not familiar with these, I don't know if this is good practice, but I just Googled data carpentry, OSU, OkState. And you can see that we have, these are also monthly workshops. In March, we're hosting it's a 2-day workshop. We'll be talking about OpenRefine, R, and SQL. So that's something else to keep an eye on. These are also meant for beginners, but they're much more intensive and they're meant to really get deep into these tools over a 2-day period. All right, so what this OSF page is a lot of the documents that I handed out. So does everyone have a handout? This? Okay. This document is there. It's this top Word document, so you can download that if you want a digital copy. I've also got the source files for the project that we're going to be creating today, so you can download those. And the link to the Etherpad, okay, which is right here. The Etherpad is this. Has everyone been able to navigate to this page? It's also on the whiteboard over there if you miss it. So this is a place that you can copy and paste code. Like so, I'm going to be asking you to type some of this out, but if you just want to copy and paste it now or later, you can get it from here. Let's get started learning LaTeX. If you are, I'm going to sign out. Okay, so you won't see what I see here. Everyone should see something that says New Project in the middle of your screen. So we all have Create First Project? Okay, great. So what is LaTeX? It looks like you would say LaTeX, right? But that's not how it's pronounced. It's pronounced either LaTeX or LaTeX. Some people pronounce it that way. And it's basically a tool used to create professional-looking documents. And it's the standard in many disciplines, especially those disciplines that write equations and have to develop complex mathematical models and communicate those. The idea behind LaTeX is you separate the formatting of the document from the content of the document. An example of this you may be familiar with in Microsoft Word is, have you ever used the styles or the heading functions in Microsoft Word, where you can highlight some text and style it a certain way? Then if you want to go back later and change that styling, you just click into the style and change it instead of having to go through your entire document and highlight and copy paste. So the same principle is in LaTeX, where you're sending commands about the formatting of the document that are separate from the text of the document. And this makes it a lot easier to control what you see. I'm sure all of us have had nightmares wrestling to get Word to do what we want it to do. Like sometimes if you're putting in images, it'll move all the text all around, or if you're tabbing over and you have different uneven tabs, or putting in, spacing that you really can't control, and it's difficult to make Word do what you want it to do. So Word is often referred to as what you see is what you get, or people will sometimes say WYSIWYG as the abbreviation. With LaTeX, it's referred to as what you see is what you mean. So you're telling the document, this is what I want you to do. Now that doesn't mean there's no problems. In fact, because LaTeX is a lot of hand coding, you're going to get problems. You're going to get bugs in the code just like you were coding in Python or R or any other coding languages that you're going to have to go through and debug and figure out what the error message is saying. And you're going to have to learn what the different functions are. So in Microsoft Word, you can just press the tab key and it will tab over. But in LaTeX, you have to understand what the tab key and code that in and tell your document, I want you to tab in this way. All right, so it is a lot of learning different functions, but that is offset by the control and the power that you have to make the document, first of all, look really nice. It produces really clean, really beautiful looking documents. And also to be very specific with how you want it to look. Also, if you do create complex mathematical equations, there are equation builders in Word, but LaTeX is far more powerful for that. Also, things like creating table of contents, managing bibliographies. So your bibliography is often separate from your document, and you create a bibliography file that you can then change the style of instantaneously. So you can put it from APA to Chicago style to IEEE, all just by coding that in. And if you're writing multi-part documents, like a thesis or dissertation, you can put each section in its own file, like the introduction, the literature review, the methods, and then weave it all into a single document. And that means you can edit each file individually. That also means if you use GitHub or another version control software, you can track those changes in those softwares so that in Word, if you delete something and save it, it's gone. You don't know what change happened. But if you're using a version control software along with LaTeX, those changes are saved. For us, we'll be using Overleaf today. Version control is built in, okay, and we'll talk about that. There's also a large number of open source packages that add on to LaTeX. So it's been around for quite some time now, and a lot of developers have created packages that increase the functionality of it. So that may be in a certain discipline, like genomics, where you need very specific layouts or very specific features. You can download and install those packages, and because they're open source, it's no charge to you. It's free to download. There's also a really large user base for LaTeX, so I came across this quote a few weeks ago, and I think it should be the programmer's motto or mantra. It's from Albert Einstein, and he said, "Never memorize something that you can look up." And so the thing is, there is a lot that this tool does, but you're going to have to Google it a lot, right? You're going to have one window open and say, tab spacing in LaTeX. But the good news is, because there are so many users, it's usually pretty easy to find. And for me, when I was preparing for this workshop, I had to Google a lot. I don't memorize all of the features. My brain says, you're not going to need this for a while. Just throw that in the trash. And then I do need it, and it's like, well, too bad you didn't use it in enough time. So, all right, does anyone have any questions? So let's go ahead and create our new project in Overleaf. And we're going to do a new blank project. And you can call it I recommend not putting in spaces, my first _ LaTeX. Let's create that. Does everyone have this? If you don't have it, put up a red sticky note or raise your hand. Okay, so LaTeX is a tool for authoring LaTeX. I'm sorry, Overleaf is a tool for authoring LaTeX documents. It's not the only one. There are a lot that you can install and download onto your own computer. So one of the first benefits is that this is cloud-based entirely. You don't download or install anything onto your own computer. You author your documents in this platform on the web, which means you have to have an internet connection in order to author with it. But it also means that you don't have to worry about having software installed on your computer. Okay? There is a function to collaborate, but it's only with the paid version. And we don't have the paid version at OSU. You can buy it on an individual basis. So if you come to use this software a lot and have a lot of collaborators, then you may find it worthwhile to pay for the version so that you can both be, it's kind of like Google Documents where you can both be in the document at the same time collaborating on it. But we don't have that, so let's move on. So there's a few things I want you to be aware of here. So over here on the left-hand side is your file tree window. So this is where you'll add, if you have multiple text documents, they'll be over here. If you add in images, which we're going to do later on, that you want to appear, data, whatever, all of your files associated with this project are over here on the left-hand side. The center panel is called the code editor, and this is where you will write the document. And you can see already, this looks like programming code, right? And that's exactly what LaTeX is. But over on the right-hand side is a PDF, and this is where it's like a preview area. So it takes whatever you're coding over here, and it lets you see a preview immediately over on the right. Okay, any of these can be hidden. So if you don't want to see your file tree, you can click on this tab, and you can click it again to bring it back. The same thing with the code editor. If you want to make it full screen, you can click on that, and you just click on it to bring it back. And the same thing with the preview. The first thing over here we see something fishy is going on, and that's because of these underscores, which I'll talk about later. So let's go ahead right away and change our title and say Introduction to LaTeX. And I'm going to try and make this bigger for y'all. Is that good? Bigger? Okay. And you'll see I put it inside the braces next to the title on line 4. Now let's hit this recompile. And we can see right away the change took effect. Let's go ahead and change our name. This pulled in from whatever we logged in with. So let's format it properly. And if you want, recompile. A couple other options as we're editing here. You see this rich text. This will render it in a more dynamic, what you see is what you get function, so less of the source code. Okay, but I'm going to keep it on source right now. And we'll talk about what some of these other buttons do later on. It's also possible to auto-compile. So I clicked this little button next to the recompile, this arrow. So what auto-compile will do is it will render the PDF every time you make a change to a line. But that can kind of take some time, especially once your document gets really long and it has to re-render it every single time you make a change. So you may not always want to have that on, but sometimes it's helpful. Okay. There's other features up here like this collaboration. Can't use it. It's going to say, you want to use this? Well, then buy the software. Anytime you make a change over here, it's not going to change until you press the recompile button. And that's part of just the way that LaTeX works, right? It takes a source code and it compiles it into a PDF. So this does it all in one place. Alrighty. You can also, let's see. If you press Control L, and I think even if you're on a Mac, it's Control and not Command, you can go directly to a line. So this is Control L. So we don't have much here now, but I'm going to just press in line 12 and press Enter. And that will take me immediately to a specific line in my document. Okay, that's Control L, and then you type in a number to navigate down to a part of your document. All right, now you may, so any questions? We good? Okay, if you've seen LaTeX written, you've seen it's kind of funny with like uppercase, lowercase. So let's do our first little bit of styling. Go back up to the title and hit a backslash and make it say /LaTeX in all lowercase letters. Now the backslash, as you can see in some of these other commands, that's telling LaTeX that you're putting in a function. Like you're not typing in text, you're actually issuing it a specific command. So in this case, if we hit recompile, sorry, that's wrong. It's capital L, lowercase a, capital T. And if you just delete it, what I did is it starts auto-completing. So just start writing it, and as it comes up, it'll be this one. So that's a good lesson for me. Use the autocomplete features. Don't think that you know better than the computer. Okay, and then recompile. And now you should see it styled in the way that LaTeX is typically styled. Okay, so what happened with one of these cases is this curly brace at the end was accidentally deleted. So that leads to an error because the curly brace is inside the title. That's telling LaTeX everything inside these curly braces is going to render as a title. So when we hit this, without that, it's going to give you some error message here. And we'll talk about error messages in a minute, but that's very common. So yeah, and sometimes, as you can see, the error messages are really hard to debug. Yeah, and you just have to kind of scan through your document and figure out what went wrong. It does highlight in the yellow text where something went wrong. And so in this case, we just closed that curly brace and we recompiled and we were back. Control Enter will recompile. All right, so what we see up in this top space is before the begin document, this is what is called the preamble. So this is where you set a number of options that are going to apply throughout the entire document. Okay? The first one you see up here is document class article. Now, there's a back-end file that feeds styling information into this. It's called a class file. You can create your own class files if you have very specific formatting. A lot of journals will have their own templates, which we'll talk about, that have their own specific class file. But that's what's telling our document here. Put the title this size, center the author, center the date, start the introduction with a 1 on the side. Right, so that's styling information that's fed in on the back end with article. You can override some of that and you can change the class file. But the other types of document classes are like book or report. And so if you are writing a book or a dissertation or a multi-part report, you'll want to look into the report or the book style document classes, because those make it much easier to weave together a bunch of different parts into a single part. But this one is specific to, like, if you're writing an article or writing just an assignment for class, just keep it with document class article. Okay? There's a few parameters that we need to set in here that we can control. And to do that, watch this carefully, we're going to add in the square brackets after the word class, but before the word article. And the square brackets are these ones. Okay? And so put it right there after the word class but before the word article. And I'd like you to type in 12 PT, 12 point. This is also on your handout. We're in the first box on page 2. So does anyone have a guess what we did here? Change the font size. Right. And so if we recompile, which we just learned, we can press Control Enter. Actually, we don't have any document text yet because that's a heading, so let's not do that yet. The next command, if you can see in your handout, is setting the paper size. So it's always good to specify that. And let's do letter paper. Recompile. The reason that this is underlined here has nothing to do with LaTeX. It's my Google Chrome running a spell check and saying it can't find the word letter paper. So don't worry about that red line. Does everyone have those settings? This line 2 came with our, when we opened up the document, and this is what the character encoding is, which is UTF-8. I'm not going to go into that right now. On our document, I'm not going to talk about this, but you can also set the language right there as well. So you see use package English from the Babel package. So what we're doing here when we say use package is we're calling on an external package and asking it to run some of the functions in our LaTeX document. All right, let's skip down to here under the introduction section. And yes?
That use package refers to.
I'll talk about that more. Yeah, you're calling on an external package and asking it to bring in some of its functions. This one here is saying encode the text in UTF-8 character encoding, which is just a way of telling computers how to understand the characters behind the lid. So let's go here to this underneath section, and I'm going to copy in from here from our Etherpad. I'm just going to copy this text here so y'all don't have to type it out. And I'm going to paste it in. And recompile. Now, a few things you might notice about this are like the first paragraph is not indented. it looks a little bit close, like the second paragraph looks a little bit close to the first paragraph. Those are some of the things, the parameters that you can set in your preamble. So I'm going to come back here to my Etherpad, and I'm just going to copy everything from line 37 to 41. Everyone got it? I'm going to paste that here in case it goes away. All right, 37 to 41, copy that, and I would like for you to put it up here on line 3. So paste it in there. And recompile, and when you press recompile, watch how the document text changes. So what are some of the things I did here? I'm not going to explain it all in detail, but line 4, indent first. That's an external package that someone developed for LaTeX that says indent the first line, because the built-in, out-of-the-box LaTeX will not indent the first line. So this is one way of forcing it to do that, right? Use package geometry. So here we might recognize the square brackets like we did with document class. So this is taking geometry, which is another package that someone else developed to help us control the layout of our document. And we're using the package geometry, specifically the margin argument. So we're setting the margin to 0.75 inches. There are lots of other arguments that you can specify here. And as you learn more about LaTeX, it's worthwhile to read more about the geometry package, so you can easily set the margins. This one, set length, paragraph. So this isn't a use package, but this is a function that I'm telling LaTeX, I want to set the length of the paragraph indentation to a 2 em dash. And then I want to set the length between 2 paragraphs to a 1 em. And the reason that I had you just copy and paste this is because I'd like for you to come away with this workshop having all of this just built in so you can start typing and controlling it. But if you're going to become a LaTeX user, it's worthwhile to go through and learn more about what all of these functions do. Okay. Does anyone have any questions? Yes.
The last one, the length between the paragraphs is
1 em.
But
Yeah.
I just wanted the same length between every line, everything contains the same space, no paragraph. That's how to say that.
So if you wanted no spaces in between,
Yes, no space.
you would just remove this argument. Here's what I'm going to do. And so watch how it changes. Okay. And there's a lot more, oops. Yeah, go ahead. Yes, you're exactly what I was thinking. So let me talk about comments. Where's my thing? Okay. So there was a good question. Can you comment this out? Does anyone who uses who codes want to explain what comment out means?
Well, it'll be just text in the compiler. It doesn't do anything.
Right. So a comment is a way of saying, of putting notes to yourself or notes to people who are using your code in the future that you don't want to be read in as code. So here's an example of that. I'm going to push this down and I'm going to put in a %, okay? A percent sign is LaTeX character for comments. And I'm going to say set indentation length and paragraph skip length. Now if I recompile this, it's going to do exactly the same thing because this percent icon is telling LaTeX, don't read this in as code. If I didn't have that percent there and I recompiled this, it's going to give me an error. All right? And we see errors in a couple of different ways. We'll see an X, hopefully, not always, but we'll see an X next to the line that caused the error. And we'll also see a red 1 over here. One of the good things about Overleaf is it does give you pretty understandable error messages a lot of the time. So some of the other LaTeX compilers give you completely incomprehensible error messages that you have to go and Google and try and figure out what it means. But this one gives you nice, clean error messages, and it will also usually link out so you can learn more about it. Okay? So in this case, it said no begin document command was found. And that's because yeah. So I'm going to put that comment back, recompile to get rid of my error message. And so when the question was, could you comment that out? Sometimes you'll write a bunch of code and you can't decide if you're going to use it or it's not really working right and you just want to move on, but you don't want to delete what you have. And that's what's called commenting out. So you would just do this and say, I don't want to deal with that right now. I'm going to leave it here, and maybe come back someday and fix it, maybe not. But that way you have a record of it and it's not going to mess up your code. Any questions? Okay, so we start with begin document. So if you're following along on the handout now, we're up at the top of page 3. All of that was the preamble. It's setting specific parameters, it's loading in the packages, it's issuing instructions for how to handle the document. Now we're actually going to start authoring the document. The first thing we see here, I don't know if our lines are the same or different. For me, it's line 17, is this /make_title. That's a function that is going up to our document preamble. It's finding the title, and it's creating a title out of it. Like this would not appear, this title, author, and date, without issuing this command. So this is saying pull in not just the title, but also the author and the date, and format them nicely at the top of the screen there. And the way that this is styled, as I mentioned, is specified in the article document class. Now, line breaks, you have to make sure and leave a blank line. Like if I start off out here and I'll say, I'm just going to press enter once after the end of paragraphs and say, I need a blank line to create a paragraph break. So if I recompile this, remember I only pressed enter once, it's going to keep it on the same line because it thinks it's part of that same paragraph. So you have to make sure and put a full blank line. To create a new paragraph. Any questions? So let's go over to this document again, and let's copy these sections, line 47 through 51. I'm going to copy those, and then after the word break, I'm going to paste them in and recompile. So what you see here is, did you see me put in any numbering? 1, 2, 3. It's all figured out automatically, right? So that's kind of nice. If you're moving a lot of sections around, if you're typing that in Microsoft Word and you're putting in 1, 2, 3, and then you decide to move one section ahead of the other, then you have to change your numbering. So with this one, it keeps track. For example, if I was to move my conclusion up here above methodology, then conclusion is going to be number 2. The other thing you notice is I have subsections in addition to sections. And so that translates over here into 3.1, 3.2. And you don't have to use this numbering scheme. There are ways for you to override it if you don't like the 3.1, if you don't want any numbering at all. I'm not going to get into that, but that's something for you to explore. You don't have to use that scheme. So how many people are thinking you will use this to write equations in here? Okay, so let's talk about equations. I'm going to go here under 29, and I'm going to press enter a few times just to give me some space. And now we're on page 4 of our document. But first, before we start writing equations, we need to load in a couple of packages that will help make writing equations easier. So let's again scroll back up to the top, and let's go under all of these instructions for use package. And this time I'm going to start typing, all right? So I'm going to hit the slash, and I'm going to start typing use package. When it starts appearing, you can press enter to complete it, and that will, so you don't have to type out the whole thing. And then I'm going to start typing AMS math, and that usually that's one of the first ones that appears. So I'll press enter, go down to the next one and do it again. Use package AMS Simb. Now I don't need to recompile right now because I haven't written any functions that use the, I haven't written any expressions here that use the functions from these mathematical packages. But when I do, it will now be able to use these. So it's kind of like an extra, an add-on, a build-in. So, all right, now let's go back down to our equations. And the way you write equations is pull this. You use a $ to write inline equations, okay? So, 1 second, please. So, you can say use $ to add equations. For example, $n for simple characters, $/ frac. This is going to, any guesses as what this is going to do? Create a fraction. And so any guesses as to why it has 2 different sets of braces, numerator and denominator? So we can do n over 2. And now I'm outside of the $. I'm going to do a comma. I'm going to do a $ again and say x to the nth power for exponents. And last one, n underscore I for indices. Now let's see if that works. And if you get an error message, that's okay. We all get them. Just put your red sticky up or raise your hand. It should look like, sorry, I'll go back to it. Should look like this. On your handout, at the very top of the page, there's some links out to mathematical syntax operators and how to write mathematical expressions. We're not done, we're going to keep going, but that's there for your reference. Now you can use $2 signs to put the equation on a new line. So you could say, let's do this, y equals m plus b, $2 signs, and recompile. So you see here, it's keeping it in line. If you use $1 sign, it keeps it in line. $2 signs will put it on its own line, and it will also center it.
And how can I name equation 1?
Great question. So what if you have multiple equations that you want and you want them labeled? That is when you will create an equation environment. So you can do this, /begin equation, enter. And you'll notice that it automatically tabs over, which is good. That will separate it and let you know you're in a separate environment from the larger document. Now you're working within the equation environment. So let's say x equals y plus 1. Now in this case, because I told LaTeX that I'm in an equation environment, I don't have to use the $sign. It automatically is going to recognize that as a equation. And let's do f equals g frac. I'm going to do a little more complex one for you. M2. Okay, so here what I want to do is I actually want this two of these. So frac, 2 braces, m underscore 1, m underscore 2. Then close the first brace. So that's my numerator. Right, so you see what I'm doing here? Remember the underscore is an indices. Sorry. And then 2 braces again, and say r squared. Let's see if I did that right. Yeah, okay. Equation is just for one environment. Sorry about that. The multiple equations is actually a line. So you do a line like this. Let's see if that worked. And with 2 slashes at the end. Okay. So sorry I confused things there. Equation you use if you only have a single equation, but you use a line if you're going to have multiple equations.
Oh, a line, not a line.
A line.
Okay.
Yeah. Okay. So we have begin a line, we have our first equation, and then we have to follow it with 2 slashes, and then we put our second equation, which I put in something a little complex just to show you it's possible. And you see over here on the side that they're numbered on the PDF document. So I'll give you, if you all don't want to put in this, you can just type something easier like X. And like I said, if you don't want to put in all this, just do X plus 2 or something like that. So I've put a few more syntax, math syntax. You can do square roots, sums, integrals. You can use capital letters, like so you would just put in, literally you would say alpha, for example. And remember, anytime you use the slash, that's telling LaTeX to, it's something special. It's not just plain text. So if I do a slash alpha and recompile, now I'll have, I don't know if y'all can see this one over here. Now there is a way to make sure that all of your equal signs align. That's in the second box on page 5 of your handout. And the way to do it is to put an and symbol at the end of the first left side of the expression before the equal sign. So what if we have multiple sections, and so later on down in the paper we have more text and we put this here. Does it continue the numbering or does it reset it? Continues it. So what I did was I just copied that. I put in more text down the document. Then I just pasted it in, exactly the same thing, and it kept track of the numbering. There was a question about how do you increase the space between. I think the answer to that is after the slashes, you put in like 2M. Let's try that. This is on. Yeah, that's how you do it. What we're going to do the rest of the time is we're going to add a figure. I don't think we're going to do tables right now, but it's covered in your handout. And we are going to add in a bibliography. And we're going to talk about how do you export it all. Does anyone have questions? Okay. So I'm actually just going to delete this here because that was an example. And let's go down into figures. So first we need a figure. We need to download one and put it into our LaTeX environment. So if we open up the this document again and go down to figures on line 75 and click on that link, we should all see this regression line. And we're going to save this to our computer. So just right click, save image as, and let's just go ahead and save it onto the desktop. Everyone follow? You click on the link on line 78, right click on it and click save image as, and save it to your desktop or wherever you want. If you're on your own computer, put it wherever you want. Just make sure you can get to it. So if you've got it saved, go back into your LaTeX document, and you're going to click on upload. You'll see that, upload, and upload the file that we just saved. So select from your computer, and I saved mine on the desktop, linear least squares, open, and now we see it appear here in the side. So put the green sticky once you have linear least squares saved in your Overleaf. Now, if you're writing a long, complex document, you may want to create folders for your figures, for your references, and we'll talk about then how you issue instructions to retrieve those in your LaTeX. Yes. Sorry? That's a good question. Let's see if that would work. I didn't try it. Mm-hmm.
Can you have a command like import something from this tab?
I think you have to save.
Yeah,
Ye-
or do you have to like click upload and upload it?
I think you have to click upload, yeah. I have not tried this from URL. Hey, that worked too. So if you have a path to a external URL, you can paste that in. Okay, so we have our, I'm going to delete this one so we don't get confused. Okay, now let's go back to our main tech document on the side. And to put an image, first we have to load the package. So you can think of LaTeX out of the box as it doesn't have any bells and whistles. It's like a car without any radio or like seat belts, and you have to load packages in order for it to really get good functionality. So we're going to scroll back up to the top. We're going to load another package, which we do with our /use package. And use package is used so often that as soon as I hit /, that's the first choice there. So this time I'm just going to press enter to use the package. And look at that. The package that we want is the first one listed, graphic X, because that one is used so often. So everyone have graphic X loaded? Let's also go ahead and load float. And float is good for helping control where stuff goes. This is can be one annoyance in LaTeX is placing documents specifically where you want it to go. And float helps with that. So do we all have graphic X and float loaded? All right, let's scroll down to our figures subsection. And we're going to call include graphics. We're going to leave the brackets empty right now, and we're going to start typing the name of our image file. So linear least square shows up right away. That saves some time. And let's recompile that and hope we don't have error messages. All right, so that's kind of big, right? We might want to reduce the size of it, and there's a few different ways that you can do that. Like we've been doing with some of our other functions, you feed arguments in the square brackets. So in this case, there's a lot of different things you can do. You can specify a height and width. You can specify both if you want it to distort it. You could also just say scale. So in this case, I could say scale equals 0.5. And recompile that. That's better. All right, I want to get to references, and we only have 15 minutes left. So for this next little bit, I'm just going to copy and paste in what I have in the Etherpad. I'm going to grab this line 80 through 85, and you can follow me if you feel comfortable doing this. But I'm going to copy 80 through 85. And I'm going to just paste that here. And recompile. And just talk through what's going on here. And comment this one out. So what's happening here, just like we created an equation environment, we're creating a figure environment. The H, that's the placement. So that's telling us where does it go. In this case, capital H means right here. Passing the command center, so I want it to be centered. I'm including what image I want, the figure that I want, and I'm adjusting the scale. I'm giving it a caption, linearly squares. And you can see here that I'm commenting on each one of these lines, right? That's a good reminder to myself in 6 months what I was thinking, so I don't forget. And then I'm also giving it a label, fig::honors. Now that label is useful because I can say C
Could you recompile why you have two figures? Should be one, right?
Yes, I'll recompile. That's good. So now I can refer to this figure in my document text if I do C/ref and then put in my parentheses and put in whatever I called it here in the label. So in this case, not the label, the number, C figure 1. That way, if I move that up or down, it's going to keep that numbering scheme. Like, so if I have multiple figures, I don't have to write each time figure 1, figure 2, figure 3, right? It keeps track of that. This label, yeah, the caption stays under the figure and the label tells LaTeX where it appears in the document. Do y'all see what I mean by that? Or did I confuse you? Like if I was to, the main point is that I don't have to write figure 1, figure 2, okay? I should never have to write figure 1, figure 2. I don't want to do that because then if, while I'm revising my document, figure 1 now becomes figure 6 because I move it further down. So instead of actually writing figure 1, I refer to it with its label, and LaTeX recognizes automatically what number of figure it is.
Each figure will get a specific label.
Yes, you type it. So I should actually put least squares or whatever. And I started off with the fig so that here ref, that could mean a lot of different things. So I know myself, okay, I'm referring to a figure, and I'm going to call it least squares. But y'all don't have to do that. Does that make sense? Any questions on that? Okay, let's do bibliography in 10 minutes. All right, we need to load packages as always. So we'll go back up to the top. And we're going to use package BibLaTeX. So you may have heard of BibTeX. That's a reference formatting kind of set of instructions. And BibLaTeX builds on that, and it adds a lot more robust functionality. So we have BibLaTeX. Now let's get a reference. So I'm going to go back to the document here, and I'm going to click on this link on line 90. Nearly every article and a lot of books will have a way for you to download the BibTeX reference for that item. It's usually in like a different place in every publisher, and they call it different things. Like sometimes it'll say export, sometimes it'll say cite, sometimes it'll say download. So sometimes you really have to hunt for it. I mean, I do this, I'm a librarian for a living, and sometimes I can't find how to download the citation. So in this case, this is one of those cases. I was like, where is cite? Where's download references? And they have it here under the arrow of download PDF. Bad design. So you go to citation, and you can see here, these are the two main types. So the library offers EndNote, which is a way of managing your bibliographic references, and you can export BibTeX files from EndNote. So that's something to keep in mind. But in this case, we're just going to click on this BibTeX. For me, it downloaded to my downloads folder. But has everyone got that? It should look like this. 10.131 journal. A lot of the different library systems have ways of downloading the BibTeX files too, so keep an eye out for them. Then we're going to go back into our deal and upload again, because now we need to get that BibTeX file from our computer into our Overleaf environment. We're going to select, and for me it went into my downloads folder, wherever y'all saved it. But after it's complete, you should have that listed there. And I'm going to click on that. A BibTeX file is actually just a plain text file. So you can open, it says .bib at the end, but you can open it with any text editor. And what you see here is like the ingredients of a reference. So these are all the different pieces that what we can do then is we can tell Overleaf, we can tell LaTeX, I want to arrange these according to a specific style. Like I want to take only the author's, if you're writing an APA style, I only want the author's last name and first initial, right? If you're writing in Chicago though, they want the entire name. If I want the title italicized, if I want the volume number italicized, all those annoying different styles you can do automatically. And that is a huge benefit. So we're running a little bit out of time. I'm going to go ahead and rename this file here. And you do that with this tool here, rename. And I'm just going to call it Bibliography. And what you want to do when you're using BibLaTeX is you can pull all your citations in and then add them into one .bib file. BibLaTeX doesn't like having lots of different separate .bib files, so you have to do some copy paste and put them into a single .bib file. And you can do that either here in Overleaf, or you can do that in like just Notepad or whatever plain text editor you use. All right, the other thing to note here is this. This portion following, so first thing you see is an article. It could be a book, it could be a conference proceeding. There's like 10 or 15 set types that you can also create your own custom types. I mean, there's a lot of flexibility here. But the main ones are like article, book, conference proceeding, book chapter. And you have to be careful though, because even though you download these files from the publisher, sometimes there's missing data. Sometimes they don't format it right. like, for example, in the author, commas are only supposed to be used to separate first name, last name. And sometimes I've seen it to where they'll have it like that. And that's not good. That's going to throw an error. So I'm just saying that to say that even though this does give you a lot of control, you have to be careful and you have to look at the file sometimes.
How reliable is
Google Scholar is spotty. Like sometimes Google Scholar will have missing data. Sometimes the capitalization will be wrong. I wouldn't rely on Google Scholar as my first go-to. First place I would go is the publisher page, whoever publishes it. And you don't even have to be like logged in a lot of times. You can just go on the article page and download the reference file, even if we don't subscribe to the journal. But yeah, I wouldn't rely on Google Scholar, because what you'll find is you open it up here and you have to add in a bunch of stuff. It's the same thing with books. There's not a lot of good BibTeX files for books. A lot of times I have to go in here and build them myself, like, to get it to work right. So we have our bibliography. What we want to do next. Okay, I was going to say this name. This is important because this is how it will be referred to. And here's a little naming convention which I wrote on page 8 in the second paragraph. Use the first two letters of the author's last name. So in this case, it's Alan, A-L. The first letter of his first name, A-L-C, and then the year of publication. And that will help you, if you have tons and tons of references, and these are all over your document, this will help you remember, oh, this is what I cited, Chris Allen, 2019. All right, everyone got it? You don't have to click save or anything. It's all saving in the background. And go to main. So now I'm going to go down to the bottom, and let's just say cite this document. And I'm going to do cite braces and then start typing. And as I start typing, it should appear, ALC 2019. Then I'm going to do print bibliography. And let's hope that worked. Nope, it didn't like something. Page 2 undefined. Okay, let me try. Aye. No, it didn't like that. What did I do wrong here? So you're seeing in real time, like, debugging. I mean, it's just a reality of working with this stuff, that sometimes you get errors and you're not exactly sure why. You've cited something which is not included in your oh, you know what I did wrong? I didn't add my bibliography as a bibliographic resource. So I have to go back up to the beginning. I have to say add bib resource and type in my file, bibliography.bib. So what it was telling me there, and that's actually a helpful, pretty helpful warning message. You've cited something which is not in your bibliography. That told me I don't have my bibliography. I didn't load it in. So that's when you have to use this add bib resource. Type in the name, whatever you called your .bib file there, and this should do it. Here we go. Okay, and so I chose IEEE style, which uses numbers. And so you can pass different arguments to BibLaTeX to say what order you want the references to go under. You can say, you know, like year, author, and that kind of thing. You can change the style up at the top. So you could say, see, I put in style equals IEEE. You can put in APA Chicago. There are resources at the first page. So we have 1 minute, less than 1 minute. I didn't tell you how to download all this stuff. The way to do that is you can either just download the PDF right here, and that'll give you your nice PDF output. Beautiful. If you want to download all of your source files, you do that. It's kind of hidden, actually. You do it up in this Overleaf menu in the top left corner. And you click on source. And when you generate a LaTeX file, it creates a lot of different extra files, like the log and some other extra files. So if you're ever sending it, you want to make sure and download this source. I'll show you everything that's in it. Yeah, so it's included. Okay, so when you export the source from Overleaf, it just gives you all of your images, your bibliography, all of the files that you have within there. Because if you didn't include those files and someone tried to compile the PDF, if you didn't include the image as well, it would say there's no image here, and so it would give you an error message. So that's why you have to include all of the other files if you want someone else to be able to recompile your tech documents. You'll see what I'm saying there. Okay, we're at time. So I hope that was helpful to y'all. My email and contact information is here. Please use this as a resource. Go back to the OSF page. You can download all of these different files that we used today. And the Etherpad will be up too if you want to copy and paste code from there, but it's also here in the OSF. Does anyone have any final questions or ideas or comments?
Could there be a second session? Because I'm writing my thesis and I really want that folder part.
Yeah, to do folder, multiple documents. We could talk about that. I mean, even if you don't need even if we don't do a second session, just email me and we can sit down and I'm happy to show you